This is a demonstration of the engineering design activity that ends the light unit in the Next Gen PET curriculum. Uh, and I'm shooting various angles of these mirrors and going to try out some of the common ideas that were either in the activity itself or in people's suggestions online. So this is actually two mirrors that are at a 60-degree angle. So light's coming in from my light source here and hitting the first mirror, and then reflecting off the second mirror, bouncing back to the first mirror, and then it does indeed bounce back along the same line as the incoming light. So in a special case, this 60-degree angle would actually work if you were on Earth. The problem is if you do not hit this at the right angle, so I'm just going to change the angle of the light a little bit, and there you can actually see the multiple reflection events. So it comes in along this line, and then it bounces over to mirror 2, but then it bounces back here at a completely different angle. And if you imagine that being on the moon, that's not going to hit back on Earth. I think the other one that the book showed us as a incorrect suggestion was in the neighborhood of 110 or 120 degrees. So I'm just going to pick 120 as another example of something that wouldn't work. You can see right now it comes in and just bounces off of mirror 1. If you get the angle big enough, you can get it to bounce off of both mirrors, but again, the angle of this outgoing beam over here is not the same as the line that this came in. You'd like those two lines to be parallel, so the right light reflected will come back to the Earth. The correct answer, which many people suggested and a couple people got really close with their line tracing at, is to put them 90 degrees apart. So if I arrange my two mirrors so they are 90 degrees apart, I should actually notice, okay, so if I take light in here nice at about a 45-degree angle, the light comes in over here, bounces over to mirror 2, and bounces back towards Earth in this example. But this design actually doesn't depend on you hitting these two mirrors at about a 45-degree angle. So notice what happens if we rotate our light source a little bit. Those incoming and outgoing light rays are at least approximately parallel to each other. If I make the angle even bigger, again, those two lines are going to be parallel to each other. I'm going to move the light source over so we can see that a little bit better. So putting two mirrors at a 90-degree angle is actually the most robust solution here for making one of these reflectors to ensure that the light comes back to Earth. If you want to make it three-dimensional, which I can't show in this video, it's actually to keep this 90-degree theme going and to put a third mirror either where you can see the protractor in the video or up here on top to make essentially the three walls that form the corner in any room. They're all perpendicular to each other. And then if you take a single laser beam and shine it anywhere into that arrangement of mirrors, it will bounce either off of one, two, or possibly all three mirrors and return back parallel to the beam that came and hit the mirrors in the first place.